Apex dropping bombs.
Hello and welcome to Data Skills Live at Edinburgh Science Festival. I'm Craig Steele, I'm a computer scientist, I'm a gadget geek and I'm interested in all things tech. And you are about to get hands-on and learn data science skills in this interactive activity. Now, data science is the set of skills that people need to ask questions of data, to collect, analyse, interpret and communicate with data. And we need more people who know how computers use data and how to use data to help humans make better decisions. And with me today, it's Digital Park Ranger, David. Hello, David, how are you?
Hi, Craig. I'm great, thank you. How are you?
I'm good. I'm looking forward to this session today.
Oh, fantastic. So my name is David. I'm a web developer, and I'm very passionate about data and technology and how we can use data to do interesting things. And I'm also a big animal lover. So saving rhinos and technology are two things that are very close to my heart. And that's why today we're here in our National Park Operations Centre near South Africa. And we have a huge amount of data at our fingertips that we're going to be dealing with. So what is data? Data is information or things that we know. So that means things like facts, figures, measurements, things that we can count. And data science is about collecting data and understanding it so that we can make decisions based on it. So today we're joined by a network of data scientists from all over the world. And by that, I mean you. You're joining us from Edinburgh, you're joining us from America, wherever you are, you're very welcome. And thank you for being here today. So let's give you some shout outs. I'd like to say hello to Donal, Kinga, and Elaine. Thank you very much for joining us. Neil, Ailey, and Jay, it's great to have you as well.
Also joining us today, we've got Abin, Kewan, and Andrew. Hello to you all. And Sarah, Heather, and Priya.
And also Irene, Erica, Kerr, and Katie. Thank you very much for joining us today. Even if we've not said your name, you're very welcome and you're just in time to join us today. So Craig, what is it that we're doing today?
The charity Save the Rhino says that South Africa has been the country hardest hit by illegal poaching. By 2017, 1,000 rhinos were being killed every year by poachers. Our park ranger, Bokamozo, has received a message that poachers have been seen nearby. We think they're preparing to attack a crash of rhinos, and we think they'll attack soon, so you need to work together. Today, you'll be our data science team and help us stop the gang of rhino poachers. First, you'll collect data from security cameras across the national park. Then, you'll analyse that data to look for patterns and suspicious activity. Finally, you'll visualise that data and figure out where the poachers are so we can stop them in time.
So, are you ready to get started? Let's watch a video to learn more about our mission today.
Let's get started. So make sure that you're on cyberskillslive.com, and then you're going to click on the button at the top that says Start the Live Lesson. Then you're going to follow the instructions on the screen and answer the questions as they come up.
Once you've gone to the website and you've signed in, we're going to start tracking your progress and give you lots of hints and tips and help along the way. So don't worry if you fall behind or if you get stuck, or even if you've never done anything like this before. We're going to make sure that you've got everything you need and we'll help you catch up. So when you sign in, it'll ask you what is your school or group, and you want to select Edinburgh Science Festival as your group so that we can see you. And I can see that we've already got lots of Digital Park Rangers joining us. I can see that we've got Callum and Emily and Ray and Daniel. Thank you for joining us so far. I can see lots more of you are already signing in. So that's very exciting. And yeah, again, don't worry if you're just getting started. You haven't missed anything yet. We're still getting things going here. If you're an adult, remember that you can tweet us at data_schools and use the hashtag DataSkillsLive and the other hashtag EdSciFest. Please use both the hashtags, it's very helpful. And we love to see all of your pictures and your messages of support because it just, it's really exciting to see.
Yeah, we've already had a message coming in, David. This is Kerr Martin's first time taking part in a data science challenge. So hello to him. And he was looking for a shout out as well. So you can, as David said, send us those messages. David, I am ready to use my data science skills to save these rhinos today. Are you?
Yeah, I'm very excited. Let's go for it.
Excellent. So this is all about data science, and we're already starting to collect some data about you. So just as David was saying there, as you sign in and as you play this activity, we can see some of the information that we are collecting about you. So I can see your park ranger name, I can see your avatar, I can see some of the questions as you answer them. And at the start, we also asked you, what is your favourite wild animal? So we collected that data by asking you that question. And now what we're going to do is analyse the results and try to understand, David, the ongoing question, what animal is the most popular? So let's have a look at the data.
So one way that we can visualize, I want to move my head. One way that we can visualize this data is to put it on a pie chart. So this is an example of a data visualization. Rather than me just reading out how many votes elephants got, how many votes rhinos got, we can see it on a chart and it's easier for us to understand. So Craig, who does it look in the lead? It looks like elephants are doing pretty well.
As people are playing live, the data is changing. You don't get this problem when you're trying to do election results, do you? As it changes while you're doing it. It looks to me like elephants are the most popular animal at the moment, followed by...
And who's following?
Hippos following the elephants as well. Considering this is a lesson about defending the rhinos aren't even the most popular animal as part of this live stream so far.
They're the underdog. I think by the end of the lesson, we might see some change in animal popularity, hopefully.
What's the benefit of having like a chart like that, David? I suppose you can just immediately look at the data and get a sense of it without having to understand all the numbers.
Well, exactly. You don't have to spend so much time trying to understand it. It's very readable. Mm-hmm. And there are different ways that you present different kinds of data. So data visualizations just make things much more understandable, which is a big part of data science, is communicating data.
We'll definitely be coming back to data visualization later in the live lesson. David, I've just got a message coming up on my screen. We are getting a transmission from Bokamozo, the park ranger.
Oh, you need to put him on. Put him on.
30 minutes until the poachers attack. Keep going.
Oh no, we need to get started.
Yeah, let's get started. So the first thing that you need to do is collect the data. So we've got security posts right across the park, which have a bunch of sensors in them that are recording data. So we need you to collect the data from those posts.
So follow the instructions coming up on your screen and let's collect the security data from the security posts.
So if you've just joined us, I can see that more people have just joined us now and you want to take part live. you go to cyberskillslive.com and you click start the live lesson. We'll make sure that you still got time to take part even if you've just joined now. So at the moment, all we've told people to do is follow the instructions on the screen. What they're going to be doing is collecting the security data. So David, what are these security posts?
So these are posts that have different sensors in them, and they collect all kinds of different data. So for example, they collect data about the weather, light levels. They have motion sensors in them so they can detect movement. But the most important thing they have is camera sensors. So these security posts are constantly taking pictures across the national park. We can collect these pictures and we can analyze them to try to find where the poachers might be in the national park. So what you need to do is download a copy of the data, and then we can start to analyze the images. So follow the instructions that are coming up on your screen. There might be a slight delay, but soon you'll have the instructions coming up on your screen. So just follow the instructions and we'll collect the data together.
Yep, I can see people already are answering some of these questions. Dono, thank you for answering these questions. Aisa, you've been answering the questions as well. That's really good. Who else can I see coming in? Rory, you've been doing a really good job here going through these questions as well. David, we've got loads of park rangers joining at the moment.
I know, we've got a glut of park rangers, and we need all the help we can get today because we've got very little time to catch these poachers. So thank you for joining us.
Emily's just joined us as well. Thanks for joining us, Emily. Just keep working through those questions. And I can see that, Daniel, you've already started downloading the images from the website. So we'll give you everyone another. I can see, David, that people are still at this point still downloading the images here. So to do this, they're using terminal commands, aren't they? They're using a little thing that they type into a computer. What is that? Like, what is the terminal?
A terminal is a way that you can give the computer instructions, and you can sometimes do things much more quickly and efficiently than using a mouse and a keyboard. It's a different interface than, say, pointing and clicking. It's a way of directly giving the computer instructions. So when we're downloading these images, we're using a terminal command, and we're seeing the text telling us how many images we've got downloaded and how many still to go.
So I can see, looking at the activity log, I can see a few of you have downloaded the images, and now you're starting to look through them as well. What do people do, David, once they've downloaded this data set of images?
So once we've downloaded all of these images, and there's a lot of images to download, so you might have to wait for it to download, but once you've downloaded the images, we're going to analyze them to see if we can find the poachers. So you're looking for an image that has a human being in it, because this could be a poacher who's coming to attack the rhinos. The problem is we've got lots of images to look through. In fact, we have nearly 16 million images to look through.
16
so
million?
we have to work quickly.
16 million
16
images.
million images.
Well,
yeah, it's a big ask.
that makes sense, because the park is so massive, and we've got these security cameras everywhere. This is based on a real life problem. How do you monitor, and how do you sort of watch something that is of that size using cameras? So it's quite normal that there's going to be this amount of images that people would need to try and check through.
It's a huge data set.
Taking part in the activity day on the call, we've also got Daniel, and you're completing the activity right now. Daniel, how are you getting on?
Yeah, hi Craig, hi David. So yeah, I've just been playing the activity along today, and the images they've just finished downloading. So I'm just answering this question here, and it's asking me to check this image to see if there's any poachers. So I'm having a look, and I've been zooming around, and I can't see anything suspicious in this picture. So I think I'm going to choose that no, there's nothing suspicious.
Okay, and what's it asking you to do now, Daniel?
So I'm just reading it here, but it says to make sure you check all the images carefully. If you see a poacher, click on the image. So I guess this is me being asked to analyze all these images, because I can see at the bottom there's a massive number, almost 16 million. So I guess I'm just going to scroll through these images and look at them all one by one and see if I can spot anything that might be suspicious. And if there is anything, I'm going to click on it.
So I can see people are doing the same as you, Daniel, right now. They're scrolling through these images. So what should they be looking for as they slowly scroll through like this?
Yeah, so we're looking for anything that could be a poacher, and poachers look like people. So basically we're just looking for people. Is there a human in the photo, or anything else that could be indicative of poachers? So I'm also looking for traps, but let's see. I think it's going to take me a while though.
Yeah, can you scroll a bit quicker? I mean, like, we've got 16 million to get through
right.
here. Although you might miss one. That's the problem.
Yeah.
Only 15,999,000 to go, Daniel. So
Well, check in with me next week.
you're making good progress.
But this is like a serious problem, because like how do you solve something like this? We're not getting through enough photos. I can see that as a team, everyone who's playing this activity at the same time, we've actually managed to look through nearly 5,000 images, which is brilliant. So keep going, keep scrolling through these images, but 5,000 compared to 16 million, that doesn't sound, I don't think we're going to get there in time. What do you think, David?
Well, I can see, even with all the help we've got, I can see Daniel and Rory and Callum are all scrolling through their images. Lots of you are working as fast as you can, but we've only really managed to process around 5,000 images so far, and we've got 16 million to look at. I don't think we're going to get through all of these in time. To be honest, we've only got half an hour to look through 16 million images. I think we need to find another way to do this.
What's even worse, David, that remember each second that the security cameras are running, they're picking up new photos, and we need to be able to check them too. There's more than 16 million now.
There's a backlog growing of more images every second, you're right. So I'm starting to think that there's actually no way that we can do this with manual labor, like manually scrolling. It's so tiring, and it's also very inefficient, and we don't have enough time because the poachers are almost here. I think we need to find a better way.
We need to find a better way to solve this than just doing it all manually. Oh, David, I've got another message coming up here from Bocamozo. Shall I put him on?
Put him on. Yeah, put him on.
15 minutes until the poachers attack. Hurry!
Okay, David, we are running out of time. We don't have enough time. We need to stop the poachers before it's too late. But let's see if we can find a way to use technology to help us. Now, computers are much faster than humans at doing some tasks. What if we could teach a computer to look at all the images for us? We could get it to do all the hard work for us.
That's exactly what we're going to do, Craig. We're going to teach the computer to recognize pictures with humans in them. So to do that, we need to show the computer lots of examples of photos that have humans in them, and lots of examples of photos that don't have humans in them. And what we're doing is we're training the computer. We're telling it what's in each photo, and it's learning from each decision that we make. This is called supervised machine learning because of the way that we're watching over the computer as it's learning. So follow the instructions on your screen, and let's teach our computer to understand what a human being looks like. And then it can do the hard work for us. We can have it look through all the images and hopefully stop the poachers. But let's keep going.
I can see that Laura has already started doing that machine learning, and Erica, thank you very much for doing that for us. Lily, I can see that you're also at that stage as well, and Florian is also doing this. I'm so glad we've got such a large team of digital data scientists taking part with us today, David.
Absolutely. We need all the help we can get. And all of your models that you're training individually are going to prove very, very useful.
And Mingu, I can see, is also taking part. And Irene is also doing a really good job getting through all these things. So
I'm seeing a lot of models getting trained at the moment, Craig, from Heather and Lily and Andrew.
So while you are training these models, I just wanted to let you know that today's live lesson is part of a project called Data Education in Schools. So the Data Education in Schools project is funded by the Scottish Government, and it's part of the Data-Driven Innovation Skills Gateway, which is basically all about creating opportunities for you to become experts in data science and data skills. And you can use data science skills to work in all sorts of areas. So we're talking about it today, how it is really used to help protect animals in Africa. But you can also use data science skills in other areas. So in healthcare, agriculture, finance, tourism, lots of elements of the public sector, but also the creative industries as well. And data skills are important across all areas of science. So maybe you're considering working in physics or chemistry or biology or computing science, then having data skills will be really useful to learn those areas. Having the skills to understand data and to use it to make good decisions is going to be important in so many different jobs across lots of different sectors.
It's totally true. There are loads of job opportunities in this area in Scotland. In fact, according to Skills Development Scotland, there are over 3,000 data scientists employed in Scotland. And what's more, the average salary for a data scientist is about £52,000 a year. So that's about double the average salary. It's a well-paid job to work in as well.
I wonder if we could bring up our little data dashboard at all to see how the sort of model training's going on here.
Do you want to explain what all this is, Craig, that we're seeing here?
So this is and you might see this a lot in data science projects. People might have a dashboard which shows them key information here. So the numbers that we're seeing on this side here, what you're seeing is the number of, if I can actually find it, there it is, the number of photos that have currently been categorized by everyone who's taken part just now. And then beside it, we've got the model accuracy. So that's how accurate your models are at the moment. So those numbers are changing. I can also see two other numbers at the side here, David, but let's focus on the safety levels here.
Yeah, the rhino safety level shows how safe the rhinos are from the poachers. So right now they're not particularly safe, and we want to get that number higher, obviously, by catching the poachers. But talking about the model accuracy, Craig, we really want this number that says 92%. We really want that to be as high as possible. So the more images that we categorize correctly as being a human or not a human, the smarter our models are going to be.
Let's check in with Digital Daniel. So Daniel, how are you getting on? What are you up to right now?
Yeah, I'm doing well, thanks, Craig. So,
I can't hear you, Daniel.
Yeah, I think I'm doing quite well at the moment. I've been sorting images left and right, whether they've got humans or not in them. So I've done 32 so far, and I'm just going to keep doing that. So I can see my model itself is currently 84% accurate, and every time that I swipe another photo, I can see that number goes up, I guess, because it's learning more, it's got more data to work on, so it's getting better at spotting people.
I can see that the overall model accuracy is getting higher as well. I wonder if we could even get it as close as maybe 95 or 96%.
Keep going, Daniel, then. Keep sorting those images. You've had your instructions from David then. So in data science, we call this image classification, and this is genuinely a way to teach a computer how to identify things. So, like, where else have we seen this before? David, have you ever had to click on, have you ever been trying to sign in a website, right? And then before it lets you into the website, you get shown a picture and it's like, click every box that has a traffic light in the image, and it won't let you in until you've done that.
Yeah, image classification problems are used in CAPTCHAs all the time, and companies like Google will ask you to identify pictures before they'll let you do something on the website, like post a comment or log in. And sometimes Google, for example, uses this data as training data for their projects. So you might be asked to identify, is this a fire hydrant or a traffic light, or is this a road marking? And they're using that data to help train their self-driving car project, Waymo. So often this data is used, and we're unwillingly or unknowingly training computers all the time.
So one hand, it's quite fun to think about it, like, you know, we're getting to train self-driving cars, but they're kind of making us do the work to do it.
Well, you should get paid.
What's your thoughts, Daniel?
Yeah, I think it is. It is quite smart getting us to do that work for them, because doing this image classification, I imagine in a lot of cases it's probably not as fun as this. Like, you're probably not looking at animals in a nice national park. You might just be looking at, like, you say, fire hydrants or looking for traffic lights, and that's really like laborious, repetitive work. So I think they're quite clever, making us do a little bit kind of every day as we log into computers. And this is just like that. We're training our computer system to spot people, and that way we can then look at these photos that have humans in them, and we can try and look for the poachers, and that's a much more manageable amount of data for us to look at. So my model I think is getting pretty accurate now. It's at 90%.
Yeah.
So I'm just
You nearly got that one wrong, Daniel.
I did.
Did you not recognise that was a human? Maybe we're distracting you by talking to you while you're trying to do this important
perhaps.
task.
Maybe I should
Daniel,
focus on
there is
this.
rhinos in danger. You need to focus. You need to get it right. Let's have a look and see how everyone else is doing with their models.
I can see that our model accuracy is approaching 95%.
Oh, that's really good.
So we're doing really well. I think we're at the threshold now where we could start thinking about testing our models to see if they're up to scratch. What do you think, Craig?
Let's do that. Let's do that. So let's move on to that stage. So basically, you've trained your model now, and this 95% accuracy is looking really good, and thousands of images have been checked here. What you're going to do now is test your model and see if it works. So follow the instructions on the screen to test your model. And basically what we're doing here is, rather than you having to check through the model, check through the photos yourself, we'll use the learning model that you just made to do the work for you. It's going to check the photos. Now, hopefully it will be much quicker at checking them than it would be for you to have done it manually. So I think people are starting to, I can see people are starting to do that now.
Yeah, I can see the models are being tested. Seeing a lot of good progress here. Thank you, Florian and Heather and Mingyu, for testing your models. That's
I
fantastic.
can see Asea has tested their model as well.
And Andrew and Donald. Nice work.
Irene's always quick in at the instructions. Excellent. What are you seeing the results, David, of any of this model testing?
I've seen the results coming in, Craig, and it's actually really surprising. It looks like our models are going to be about 14,000 times faster than doing it manually. That's a massive improvement.
14,000 times quicker.
Roughly 14,000. Now, obviously, it's going to vary from model to model, but that's a really massive improvement from when we had 16 million images to look through by hand.
Yeah, I mean, exactly. When Daniel was having to scroll through those images manually, there was no way that he was doing, he might have been doing about 2 or 3 a second, but to be able to do 14,000 times that per second, that gives us a much better chance of getting through these 16 million images and spotting the poachers, because, I think that we're at a point where, the rhinos are in danger. We need to get a move on. So one thing that we might do in a second is we can combine our models to form a potentially stronger solution. But I think for now, David, maybe we should check in with Daniel.
Sure. Yeah. Let's see how he's getting on.
How you doing?
Yeah, that's actually really good timing there, Craig and David, because I was actually just getting to the bit where it's currently asking me to look at this theory called Ensemble Learning, of combining the models to get a more accurate or more trustworthy, more results. So I've got the results here from a load of different models. There's about 100 models here, and most of them are predicting that there's no humans, and some of them are predicting that there are humans, but almost all of the models have predicted that there isn't a human in this particular image. So I think that's the conclusion that I'm going to come to as well.
Oh, excellent. So we can be a wee bit more confident if a majority of the models are giving us the same answer. We kind of think, oh yeah, that's probably right.
Yeah, exactly. So although all of our models are really good on their own, if say we asked 100 of them, and then almost all of them said this photo does have a human or this photo doesn't have a human, we can really kind of be quite confident that we've definitely got the right answer there.
Yeah, we don't want to accidentally send a helicopter to investigate a poacher that turns out to just look a bit like it's just a tree that looks a little bit like a human. So what you're doing now, Daniel, it looks like you're going to upload your model to us.
Yeah, so this is the terminal that you were talking about earlier, and I've got a command here that I've got to type in. In fact, I've just copied and pasted it to compress it to make it smaller so it uploads a bit quicker, because I know that this is something that can take a while, especially so in a national park that might be a bit rural. The broadband might not be quite so good. So that's it compressed now, and I've got a new command. It says scp models.tar.gz. Okay, so that's the compressed file, and I'm putting it to a location called our server. So it's the models folder in a server. So let's just start the upload going just now. So done 1 megabyte.
I think it's worth mentioning, Craig, that even if we're not on this stage yet, I know some of us are still answering questions from earlier on. We've got plenty of time. So we're making really good progress. So just keep answering the questions, whatever part you're looking at. And you might have to wait a little while, as Daniel mentioned, for the broadband, for the model to upload because of the rural internet.
I can see people have already. Callum's been able to upload their model. Heather's currently uploading their model as well. Thea, thank you very much for sending that in. Rory also doing a good job here, uploading the model too. It's going to be so good that we're going to be able to combine these, hopefully. Daniel, what's the progress like?
Mine's gone quite quickly. It's already at 70%, so I guess that's a bit quicker than I expected, but maybe some other people might take a wee bit longer.
If you're going to be in charge of defending the rhinos again, we might have to invest in a bit of a quicker internet connection, because the sooner we get these models uploaded, the better.
Oh, there we go.
Ah, nicely done. So now, once you've got to the point where we've uploaded our model, I think we need to start thinking about next steps, Craig. What do we do once we've uploaded the model?
Yeah, so what we can do is I can now see that quite a lot of people have sent in their models, and what we can do is we can combine our models to form that potentially stronger model that Daniel was talking about. So to create that more accurate model, I've got a program here that I could run on my computer that will start to combine them all. Shall I do that now, David? Have we got enough?
Absolutely. I can see a lot of people have uploaded their models, so I think time is of the essence.
Just run it. David, it worked. I've been able to combine all the models, and now we should have a more, we should have a stronger model that we can hopefully be more reliable for what we're using it for.
Yeah, absolutely. And we did say that if we were to do it manually, because we've got 16 million images to check, and there are new ones coming in every second, it would take about 2 years for us to look through all of those photos by hand. Now remember, we've got like 20 minutes.
Yeah,
we don't have 2 years.
Have 2 years to go through all the photos. We've got about 10 minutes left.
So I think what we should do, Craig, is once we're ready, we should try running this machine learning model that we've created against the full data set, all 16 million photos, and see how quickly and accurately it can categorize them. And then hopefully we'll be able to spot where the poachers are.
Let's go.
What do you think?
Yeah, run it, go for it.
Let's go for it.
David, that is so much quicker.
That's incredible.
Look at all those images.
Look how quickly it's going through each one. It's just flashing by.
Millions have already been checked. This is so much quicker than doing it manually.
This is 2 years work in 2 minutes.
Oh, we're about halfway there.
Not long to go now.
Here we go, here we go. 1.5 million left. I think we're going to be able to do it.
Fantastic.
Yes. Wow,
there we go.
We did it. Oh, David, that was so much quicker than 2 years worth. So because you trained your model and made it really accurate, we were easily able to check all 16 million photographs for poachers. And as a result of that, we've got the output. So we've got a list of predictions of where the poachers might have been seen. So we know the location that those photographs were taken. We could use this to try and narrow down to where the poachers might be.
Craig, I'm sorry to interrupt you, but I've just had an urgent message coming through from Bokamozo. He sounds like he's panicking a little bit.
Put him on.
5 minutes until the poachers attack. Quick, tell me where to send the chopper.
Okay, we are nearly there, but we need to be quick. We have the data, but we need to be able to understand it. Now, this is location data that we're talking about here, and we're talking about visualizing data. So the best way to visualize location data would be on a map.
Yeah, absolutely. So what we need to do is follow the instructions on your screen, and let's prepare this data for visualization on a map. Once you've done that, you'll be able to tell us which group of rhinos is under attack, but we have to prepare the data before we can see it on the map. Remember, we don't have much time. We've only got, what, 5 minutes, Craig?
Less than 5 minutes.
Not much time. So let's keep working calmly. Sorry, I'm getting stressed out here. Let's work calmly and quickly and see if we can clean and prepare the data so that we can map it.
I can see a lot of people are playing along right now. I can see that we've got a young data scientist. Kate is playing along with their 8-year-old. So that's exciting. Probably early exposure to data science.
Fantastic.
Saving the rhinos is a good day for an 8-year-old. I think that's a good afternoon.
Yeah, absolutely.
So I can see that people are starting to clean that data now. They're starting to visualize it on the map. Hopefully, David will be able to narrow it down to the group of rhinos that are under attack. Let's let people keep going with that.
Yeah, I'm seeing a lot of data getting prepared and answers being sent in for where the poachers might be. So keep going, keep working. Excellent work so far.
Thanks, Laura. You're sending us in some information. I can see you working through it just now. Ted, I can see you're taking part as well. Thank you, Dono.
And Emily and Ted. Oh, sorry.
No, go for it. Do some shout outs.
Erica and Andrew and Emily. Nicely done.
Some people think they might have been able to identify the poachers on the map. I think we need a bit of a consensus though. Like, I'm not just going to take... I can see Andrew sent one in. I don't want to, I mean, no offense, Andrew, but I'm not going to just take your words alone. I think we'll have several people's results, and let's
get a few more answers in, because remember, we're sending a helicopter out to deal with them. So we want to be confident that we've got the right people.
I can see more people accessing it now. David, I'm getting a little bit stressed as well here with all these rhinos, but we'll give it another 1 minute or so. I think we're nearly there. A lot of the answers that are coming in are the same, so that gives me confidence.
Yep. That's good. That's a good sign. And Laura and Ted have sent in answers as well. Nice work. And Dono, thank you.
I think Emily sent in where she thinks the poachers might be on the map as well.
Fantastic.
Thanks, Emily.
What do you think, Craig? When do you think we can be confident?
Let me have a look. Okay, this is all coming out. This kind of looks about right. Okay, David, I think we know the name of the rhinos that are under attack. I think we know. We think it's Umatatu. We think the group of rhinos under attack are Umatatu. Can you let Bokamozo know?
Umatatu. Are you sure about that, Craig?
I'm seeing the answers here, and that's what's mostly coming in. So can you let Bokamozo know?
Yeah, I'll WhatsApp him. Hold on, let's see what he says.
Apex dropping bombs.
I hope we're right.
Fingers crossed.
You did it! I've sent the helicopter. The park rangers are on their way.
Yes,
Oh,
yes, David.
amazing.
We did it. Well done. We figured out that the group of rhinos that was in danger is Umatatu. We've sent a helicopter out to deal with the poachers.
Well, that's fantastic work. That was a lot of work in a very short space of time. You had to download a data set of 16 million images, which is no small task. And to do that, you used a terminal to give the computer instructions. And then you experimented with processing the data by hand, but we realized it would take far too long to look through 16 million images. We realized it would take 2 years to do all that manually. So instead, you trained a machine learning model to look for humans in photographs. And we ran that model against the entire data set of 16 million images. Finally, you created a data visualization to understand this data. You used a map, and then we looked at the map to find where the poachers are in the park and sent out a chopper to deal with them. So well done. That's a lot of work in a short space of time.
Thank you for being part of our data science team. We couldn't have done it without your help. Your hard work in training the models and using your data science skills has kept the rhinos safe, at least for another day. Now, there's one last task that we need you to do, and it's important. We need you to answer some questions about today's event and tell us what you thought.
So click continue and answer the questions that come up on your screen. And if you're a teacher or a parent, remember, you can tweet us a photo of your report card to data_schools and use the hashtag EdSciFest and the other hashtag DataSkillsLive. We love to see your tweets. And to be honest, Craig, I've had so much fun defending the Rhino today. I hope that you guys will join us again for another data science adventure soon. You can always keep in touch with us by visiting our website, cyberskillslive.com. And there you'll find all of our exciting activities about data science and computing, and you can take part in them anytime you like.
And David, don't forget where we are today. We're on YouTube. So what should people do if they've enjoyed the video today?
They should definitely like and subscribe.
That's right.
And keep it
like our video, subscribe to our channel to
Participate.
keep up to date with these more activities like this. So that's another way that you can leave us positive feedback, just liking the video. And I can see some of you have already done that already. Thank you very much.
Thank you very much.
To find out more about working in data science, you can go to the Data Education in Schools website. Make sure you tweet us on these accounts. But David, I've had a fantastic time this afternoon defending the rhinos with you.
Yeah, it's been great. Thank you for having me, Craig.
Well, when times are in crisis, we need to assemble a team like this. Also, thank you to Digital Daniel, who's been playing along the activity with us today. But most important...
And Bokamozo as well.
Bokamozo, of course.
Don't forget Bokamozo.
Yeah. So most importantly, thank you for taking part at home today and for being part of what we are doing at the Edinburgh Science Festival. If you want to do more of these types of activities, David, we have 15 other interactive activities that you can play along with. If you go into the Edinburgh Science Festival website and you look under what's on, you can find them all on our website and you can find them all on their website as well. But for now, it is goodbye from Data Daniel. It's goodbye from Bokamozo. Goodbye from David.
Bye.
And it's goodbye from me as well. Bye-bye.
Apex dropping bombs.